Hey guys, Mr. Milton here. Today we're going to do notes on triangle congruence by side, 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 and side, angle, side. At the end of this video, you should be able to identify side, 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 and side, angle, side congruence between two triangles, and you should be able to begin to prove two triangles are congruent formally. Okay? So, reminder from last lesson, how many parts have to be congruent in a triangle before we can say that the triangles are congruent? Well, that answer is 6. And that's because there are 6 parts, 3 sides and 3 angles. Okay, we have 2, 3, 4, 5 shortcuts that allow us to prove triangles congruent. Each shortcut requires 3 parts to be congruent instead of 6. However, it does matter the order that these parts occur. So if you're thinking about, we're able to cut our work in half by understanding and using these shortcuts. So probably important for us to learn and be able to apply. So here you go. First 2 shortcuts we'll deal with today. You already can see that in the title. Side, side, side postulate and side, angle, side postulate. Okay, the side, side, side postulate says if 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. And so you see an example here. Remember, it's very important to understand what the notations mean. Mark for AR, mark for HC. That means AR is congruent to HC. Also important to remember that we have to use write our congruent statement in a way that our corresponding angles and sides match up. Okay, so as I make a congruent statement here, I'm going to make sure that I follow the same pattern in markings so that I say which triangles are congruent to which. So for this first triangle, I'm going to go from 1 hash to 2 hashes. So ARN. Triangle ARN is congruent to triangle. And so it's important, as I have established kind of my rule of how I want to name this, 1 hash to 2 hashes. I'm going to do that same thing here. 1 hash to 2 hashes. I want to say triangle HZP. And so now I have it set up so that triangle ARN is congruent to triangle HCP. And if I were to do congruence, I'd say, okay, R must be the same as Z. RN must be the same as ZP. Okay, so very important that we're able to understand how to write those congruent statements and why they are how they are. Okay. Second shortcut or congruence postulate here is side angle side postulate, SAS. Okay, if 2 sides and the included angle, and so this might be a new term, we'll look at this in a second, and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. Okay, so first we need to identify what an included angle is. And an included angle is just the angle that is between our 2 sides. Okay, so as we look at our first triangle, HYD, we say, well, which would be the included angle in this triangle? Well, since HY and HD are marked, our included angle would be the angle that is between our 2 sides. Okay, our 2 sides meet at that angle. This is the included angle. Okay, and so which was the included angle? We'd say angle H to answer that question. Okay, you can try that with B. And here, as we look at it, we're given that FG is congruent to L, okay, because of the hash marking. Okay, and we can figure, because FK is part of both triangles, that it is congruent to itself by the reflexive property. Again, I like to make that mark just so I can see my markings and be more visual with calling my 2 triangles congruent. So now, the other marking that you might have noticed is these 2 arrows. Remember, that indicates that our LK and FG are parallel to each other. And so going back to last chapter, we see, okay, parallel lines, we have a transversal, we have alternate interior angles here. And notice about this angle LKF and GFK that these are included angles. Okay, they're between our 2 marked sides. So name the included angle in each. So we'll say angle LKF and angle GFK. do want to point out the importance of naming our angles correctly here. We were able to name this angle H because there's no confusion. There's only one angle H. Here, we would not be able to call this angle F and this angle K, right? Because angle F could refer to this angle GFK, or this angle LFK, or this whole angle LFG. Okay, same with angle K. So make sure that we're specific in naming those. Okay, but hopefully you see how you can tell what an included angle is. All right, so here we go. It says in our example, can we conclude that the triangles are congruent? If so, give a congruent statement and justify. If not, tell what other information you need to prove them congruent. Remember that a congruent statement is just what we talked about at the beginning. We're saying like triangle, ABC is congruent to triangle DEF. Okay, that's our congruent statement. Justify, remember, we don't need to have a paragraph or anything like that. We can justify with a postulate or theorem. In this case, probably either going to be side, 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 or side, angle, side, since that's what we're dealing with now. Okay, but as we add to our shortcuts, that's our justification. Okay, so here, we're given this information. It says, can we conclude congruence? Try to answer that question. And hopefully you came to the answer, no, we can't. Okay, and here's why. Even though we're given side and angle on a side, remember for side, angle, side, we need an included angle. Okay, and so even though we're given an angle in both triangles, it is not an included angle. And so we cannot prove that these two triangles are congruent to each other. Okay, and more specifically, we need angle T to be congruent to angle V. This is the other information. This is the best answer. If you saw something like this on a quiz that asked what other information will we need, I'd rather you say, I need this, than saying an included angle and being general. Being specific and saying angle T being congruent to angle V is the other information we need. All right, next example, it says, can we conclude congruence between these two triangles? Okay, and so as we look at these two triangles, you might say, well, we only have two sides marked. So no, but remember that we do have MK and it's a part of both triangles. So I'm going to mark this to help myself and see it visually. So yeah, reflexive property says MK should be congruent to MK. So can we conclude congruence? Yes, we can. So now we have to work on using a congruent statement. And again, I'm going to go in my pattern. I'm going to go 1 hash to 2 hashes. So KJM. So triangle KJM is congruent to triangle, and 1 hash to 2 hashes, MLK. MLK. Again, I'm doing this not because I'm randomly choosing these. I'm trying to set up a pattern so that I follow the corresponding angles and corresponding sides in the same place. Okay, again, justification, not a whole lot of space here because I don't need to write a lot of words. What's my justification for saying these two triangles are congruent? Side, side, side postulate. Okay, and I'll just write side, side, side. Okay, and so we don't have to worry about no, because no's not the answer. All right, so talked about going through and formally proving two triangles are congruent, and that's by using a proof. Okay, and typically we'll use 2-column proofs. There are other types of proofs. We might look through a flow chart or paragraph proof, but 2-column proofs usually are adequate to explain. Okay, so it says prove that triangle ACD is congruent to triangle ECB. They gave us this information that C is the midpoint of DB. So my statement, I'm going to start with that given information. Okay, and they give us information a couple different ways. Okay, one, they gave us information here, but another, they gave us information in our diagram with the marks already given to us at the beginning of this problem. So I want to say AC is congruent to CE, and that was given. Okay, and I'm going to add to this, again, the other given information that C is the midpoint of DB. Again, that's given. Now, typically, when I'm given information, it really won't matter unless I can mark it on my diagram. Okay, and so AC is congruent to CE is marked on my diagram. Okay, so I'm really looking for 3 marks, to show my shortcut. If I'm not able to mark it, that should lead me to think I can do more with this information if it's important. So here, there's nothing I can mark to say that says C is the midpoint of DB. So I have to think, how can I build on this information? If C is the midpoint of DB, what does that tell me? Okay, C is the middle of DB. That must mean that DC is congruent to CB. DC is congruent to CB. Now, why would I be able to say that? Well, C is in the middle. And so by definition, a midpoint cuts a segment in half. And so when I explain that, I'm going to say definition of midpoint. And you'll see definition of a lot with our proofs because we'll be saying like, basically, that's what a midpoint does. Okay, and so that's basically what I'm saying. If C is the midpoint of DB, then DC is congruent to CB because that's what a midpoint does. But instead of writing because that's what a midpoint does, it's definition of midpoint. Okay, and I kind of get to mark this like, hey, that was something I was able to mark on my diagram. I'm looking for at least 3 things that I can mark on my diagram and see if I have a shortcut that applies from that. Okay, and now as I'm looking at this, I have 2 sides, and so I could either have a way to prove that AD is congruent to BE, or a way to show that I have side angle side. Okay, I don't want to force either one, but I know that's what I'm looking for right now. And as I look, I say, oh, these 2 angles should be congruent to each other. Okay, because these are vertical angles. And so now I have angle ACD is congruent to angle ECB because vertical angles are congruent. And I'll just say vertical angles. It'll be my little shortcut here. And again, I was able to mark this on my diagram. And so now I see I have 3 marks. Okay, and I'd say, do I have a shortcut? I have a side. That was a side. This is an angle. Let's see if it worked out. Side included angle side. Yep. And so now I can prove, and I have proved, that triangle ACD is congruent to triangle ECB. And remember our reason, the reason that we can say that is our shortcut, is our justification, side angle side. Quick note here that even though we were using this given as the reason for our first and second pieces of our first and second statements, a prove will never be the reason for anything that we say. Won't say like, oh, we said it because you told me to prove it. No, we said this because we were able to prove this because side angle side postulate. Okay, all right, so that is our first congruence shortcut, side angle side, our first 2, I guess, side angle side and side 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 postulates. All right, see ya.